Alrighty, well, hopefully I think this is going to be our last video here. I'm going to go through another couple of examples, 3 and 4. These will be posted, of course, under our notes a little bit later, but I'll talk through them here. Okay, this example is going to be very similar to the previous ones. Okay, the velocity v of t in the table below is increasing from a time of t equals 2 to t equals 12, right? Approximate the total distance traveled and find an upper estimate of the travel distance using n is equal to 2, that's 2 subintervals, n is equal to 4 subintervals. Now, in this case, we're going to focus not on the difference between the overestimate and the underestimate, but what happens if we choose different numbers of subintervals, how that affects our estimate. Okay? In this case, so we've done, here's going to be the estimate with 2, here's going to be the estimate with 4, and in both cases they want us to use an upper estimate, right? So that means we're going to use the overestimate with the rectangles protruding, poking out above the graph, okay? But first, like the last one, let's go ahead and graph our data. Okay, so this is from 0 to 12. So 0, so I'm going to 1, 2, 4, 6, 8, 10, 12, right? So this is 2, 4, 6, 8, 10, 12, just like that, right? And then the speed up here goes up to 45, so 10, 20, 30, 40 should be enough. And so here is, everybody see that? Yeah, 20, and then 30, and then 40, right? And then here it says so let's graph the data. So at time 0, it's going 34, miles per hour or whatever. So that's about there. At time equals 3, it's going 37. Now 3 is, on our scale here, is right there. So at 3, it's going to be 37, which might be about there, right? At 6, it's going at 38, which might be about there, right? At 9, which is right in between 8 and 10, there at 9, it's sped up to 40. And at 12, it's all the way up to 45, which is about there, right? So now we've got an approximate graph of y equals to v of t, our speed function, right? And you see it's an increasing function, right? So now we want to estimate the distance traveled between 0 and 12 with this vehicle or whatever it is that's accelerating over time. So let's mark off our interval. Okay, we want to go from 2 to 12. So that's going to go from here up to here, right? So far, so good. All right, 2 up to 12. And now it says we want 2 subintervals. Well, okay, so we'll do that over here. We have to figure out how long each subinterval is. So in other words, we're going to see 2 rectangles here, right? So the time elapsed is 12 minus 2, that's 10. We want 2 subintervals. So 10 divided by 2, that's equal to 5. So each subinterval is going to be 5 intervals. So in other words, delta t is going to be 5. Well, that's convenient because notice that our total interval length is 10. So that just means that the first interval is going to be from 2 and then 5 more units up from 2. So that's 3, 4, 5, 6. So that's going to be, 1, 2, 3, 4, 5 units. That's going to take us up to 7, you understand. Because this is going to be from 2 up to 7. We add 5 onto 2, and that takes us up to 7. We add another 5 onto the 7. That takes us up to 12. So now here are our 2 subintervals. Delta t is equal to 5. Delta t is equal to 5, just like that. Now we want the overestimate, the upper estimate, meaning we want the rectangles above. So that means you can see here that we're going to use 7 as the end of our interval and 12 as the end of our interval. Well, we can see that it's, okay, we can see that to make the upper rectangle, the oval rectangle, we're going to use the right side here to make the rectangle protrude above. So on increasing functions, you can see that the upper rectangle, that on increasing functions, the right side sum gives us an overestimate, which is the opposite of the decreasing function. Okay, now that's going to be, now the right side boundary for this subinterval, the 2 to 7 one, ends at 7, right? Well, they didn't tell us 7. Well, can you see that? So we don't, again, we're just estimating here. So I'm going over to the graph here. I'm thinking that looks, well, it's more than 38. It's less than 40. What the heck? Let's call it 39, right? Because that's as close as we can get to be between 38 and 39, because 6 is between, if t is between 6 and 9, the speed, y, would have to be between 38 and 40. So let's call it about 39, right? It's close enough. So that means we're going to have two rectangles, 40, 39 with a height, and 45 with a height. And so, and the width is 5, so 5 times 39 and 5 times 45, we're going to add those together, right? 5 times 39, right, plus 5 times 45, I'm getting 420, right? Because 5 times 39, that's 195, and 5 times 45, that's 225. So this rectangle here, this is the 195. This one is the 225, right? And so we add them together and they come out to be 420. So our estimate, our upper estimate, our overestimate for the area under this curve, which is the distance that the vehicle traveled from 2 to 12 seconds or whatever the units are, we're going to say it's a distance of 420, right? Now we'll do it again, but with using 4. Instead of 2, we're going to have 4, right? So here is, we're going to scale the graph the same way. 2, 3, 4, 5, 6, 7. No, that's not how it was done. Sheesh. Pay attention, Waters. Sorry. 2, 4, 6, 8, 10, 12, right? And then 10, 20, 30, 40, right, are the same speeds, right? Now we're going to divide this up into 4 subintervals. We're still going from 2 up to 12, and the speed at 0 is still about 34, and the speed at 3 is still about 37, right? And the speed at 6 was still about 38, and the speed at 9 was still about 40, and at 12 it's up there at 45, right? So it's the same distance function, or the same speed function, right? And we're still trying to find the area underneath, but now we've got 4 subintervals. Well, the time elapsed is still 12 minus 2, which is 10, but now we divide 10 by 4. Well, that's, right, 10 divided by 4, that's 2.5. So that means we want subintervals that are 2.5 in width. Now this is a little inconvenient, right? But it'd be nicer if there were like 5 subintervals, because then it would come out to be 2, right? But anyway, let's find this here. So starting at 2, so if we start at 2, add 2 to that, 2.5 to that, that's 4.5. So the next subinterval, here's 5, here is 4.5. Now we add 4.5 on. We add 2.5 on the 4.5, and that's 6, and that's 7. So maybe you can see an effect. We're going to take these two intervals here, and we're going to be dividing them half, right? So halfway between, so we start at, that's now 7. 7 plus 2.5, that's going to be 9.5. So here's 9, and so 9.5, and you can see all we've done here is we divided these intervals here in half, right? And we still want the upper estimate, so we're still going to connect on the right so that our rectangles are above. Right, there are our rectangles. So you can see that we've got to get the height at 4.5, the height at 7, the height at 9.5, and the height at 12. Those will give us the heights of our rectangles. Well, at 4.5, again, we're just going to kind of estimate from the graph. At 4.5, it's somewhere between 37 and 38. So let's call it, 37.5, right? Gives us the roundest number that we can. That's between, that might be halfway between 3 and 6. So 37.5. So this rectangle here is going to be 37.5. This is the rectangle at 7, which we already decided was 39. This is the height at 9.5. Which is, between 9 and 12, halfway between them. So halfway between 9 and 12 is 42.5. So we're going to let 9.5 be about 42.5. So this height here is about 42.5, we estimate, and that one's going to be 45. So now we find the areas of those, okay? Here, the delta t, should have written here, delta t is 2.5, right? So that's 2.5 times 37.5, 2.5 times 39, 2.5 times 42.5, and then 2.5 times 45, right? Now, I'm just going to add those, 37.5 plus 39 plus 42.5 plus 45, and then multiply it by 2.5, and that's 410. That's what that comes out to be. Okay? Now, so you see we don't get the same number. Okay? In this case, it happens to be a little bit lower. Now, that makes sense because notice that this is an overestimate, right? So this number 420 is bigger than the actual area under the velocity curve here. Well, this one, because we've divided it into smaller triangles, there's less wasted space, or rather less, excess space, right? This has got more excess space. This has got a little bit less excess space. So this is a smaller number because what's happening is it's going to get lower and lower and lower and closer to the actual value, right? So that's so it turns out that if we have more rectangles, the more intervals and the more rectangles we have, the closer we are to the actual area under the curve. More about that later. Okay, very good. So let me see. We're 15 minutes in. So I'm going to go ahead. I'm going to end this video here. And we're going to do one more for example 4. Stay tuned.